All right, we're going to dimensional analysis next, which is really a very fancy way to say unit conversions. So we've done this a little bit before, but now it's like unit conversions round 2. It'll get a little bit more complicated here. So most of our techniques are the same as we did before. So let's look at this. We got a bike and it's going 12 miles per hour. Per means fraction. The word per means fraction. So 12 miles per hour looks like this. And we're converting a couple things. Okay. So part A is, it wants to know how many feet per hour is this? Which is a weird thing. Nobody really talks about things in feet per hour for a lot of things, but I'm sure there's some things where feet per hour might make sense. I don't know. But that's what it wants you to do first. So the miles part is good. And we're going to start with this. 12 miles per hour. But we don't want miles here. So just like before, we're going to convert this to feet. So we want the miles to cancel. So we have miles in the denominator. We want to convert it to feet. So we're going to have feet in the numerator. Right? Because now the miles cancel with the miles. And now we have feet per hour. But we can't just multiply by whatever we want. That's cheating, and it changes the answer. You get the wrong answer. We have to multiply by 1. So how many feet are in how many miles? And there's 5280 feet in 1 mile. So this becomes our fraction. All right. So if we multiply this all out, 12 times 5280 is some number. 63,360 feet every hour. We are moving a lot of feet. Okay. And that's all there is to part 1. Part A. So now it wants us to take our answer from part A and convert that to feet per second. And we'll do it very similarly. We start with what we have, 63,360 feet per hour. And we convert this to feet per second. So now the feet part is good. The hour isn't good though. We want seconds. So we say, okay, we need hours on the top here, so they cancel. And what do we want on the bottom? We want seconds on the bottom. And then you might want to do this in 2 steps because it's not super obvious how many seconds are in an hour. You might want to convert it to minutes first and then seconds afterwards, or you can just Google it. But it should be 3,600 seconds in an hour, I think. 60 minutes in an hour and 60 seconds in a minute. And so we just multiply this all across. And we're going to get 63,360. The hours cancel. We have feet on the top, and the bottom is 3,600 seconds. And now we just need to reduce and simplify this fraction right here. So we go over to our calculator and say, calculator, how much is 63,360 feet divided by 3,600 seconds? And our calculator says, why, that's exactly 17.6 feet per second. And you say, thank you, calculator. And the calculator says, you're welcome, Brian. And you say, how do you know my name is Brian? And the calculator says, I've been what? It's too weird. Part C. How many feet will the bicycle travel in 50 seconds? Well, it's traveling this many feet every second. So in 50 of those seconds, it's going to do 50 of these distances. Okay. Another way of looking at this, again, you don't have to do things the exact same way I do. But another way of looking at this is we have 16 feet per second, and we want to know how far do we go in 50 seconds. That's multiplying it by 50 seconds. Well, the seconds are going to cancel. But again, it's really just multiplying the 17.6 times 50. So we're just left with feet as our units. Multiply 17.6 times 50. And you're going to get 880. That's how many feet we're moving in almost a minute. Voila. Last example problem. Example 112. Oh no. All right, we'll start a new page. It's okay. It's okay. I have the paper for this. Example 1.12. We have a 1,000-foot spool. Oh, we got to pull this up. We have a 1,000-foot spool of bare 12-gauge copper wire, and that wire weighs 19.8 pounds. And the question is, how much will an 18-inch spool of bare 12-gauge copper wire weigh in ounces? So one of the things that trips up a lot of people is when there's numbers in the problem that aren't mathematically relevant. So the 12, it's a 12-gauge copper wire. That's the kind of wire it is. But we're not using 12 anywhere. It's just a description. It's like saying it's a red wire or a blue wire, right? It doesn't change the math here. Okay, so that's what we're going to look at. So let's organize our data, right? If we have 1,000 feet of wire, that's 19.8 pounds. And the question is, an 18-inch spool of wire is how many ounces? So what we're going to do is we're going to find out, well, how much, there's a couple of ways of doing this, but we could say, okay, how much does every inch of wire weigh? We can multiply that by 18. We could get everything in the same units and do proportions. There's a lot of ways of solving this problem. But the main issue here is that we are all in different units. So let's convert to find the ratio of length to weight. And we can choose either one of these to convert. But we want to convert them to have the same units. We need the same units. Otherwise, we're comparing apples to oranges. So, again, there's a lot of different ways of doing this, but I'm going to say, let's look at 100 feet per 19.8 pounds, and let's convert this to inches and ounces. So to convert feet has to be on the bottom so they cancel. Inches are going to be at the top. How many inches are in a feet? There are 12 inches in 1 foot. Great. So we can multiply this out, and now we're going to have inches on the top, which is great. But we also need ounces. So we need to cancel pounds. So pounds has to be in the top, so it cancels. Ounces are going to be in the bottom. I always forget. I always get fluid ounces confused with the other ounces. I think there are 16 ounces in a pound, right? 16 ounce to pound. American system is silly. Yeah, 16 ounces in a pound. So now the pounds are going to cancel. And what are we left with in units? Inches and ounces, exactly like we wanted. So let's multiply this all across and see what we get. So when you multiply this is going to be 1,000 times 12 times 1 divided by 19.8. Be careful to use parentheses when you're dividing, and 16. This is going to be equal to 37.87 repeating, and our units here are inches per ounce. So now we can set up our proportion. Okay. Again, there's a lot of different ways, but actually flipping this ounces per inch is probably more useful. Ounces per inch, and then we could just multiply it by 18. A lot of different ways you could solve this problem. My way is kind of a little silly. But this is the like a standard mathematical way that works. So we could set this up as a proportion, 37.87 repeating inches in 1 ounce. And that should equal the 18 inches in our X ounces. And we can multiply this all across and solve. So we do that, we get 37.87 repeating times X equals 1 times 18. Divide both sides by 37.87. We should get that X is equal to 18 divided by 37.87. Repeating. We'll type that into a calculator and get 18 divided by 37.8787878787. That's probably enough. And we'll get 0.4752 exactly. This is exactly, according to my calculator. Now, what are we answering? This is how many ounces it should weigh. Okay, so not very many ounces. It's pretty light. Which I guess should make sense, right? 1.5 feet, 1.5 feet of this wire. I don't know how big the wire is. Wait, I do know how, wait, no, I don't know what 12 gauge wire means. I don't know what a 12 gauge copper wire is, but it's pretty light. But I guess if 1,000 feet is only 20 pounds, it should be pretty light, right? 1,000 feet, that's like 1/5 of a mile. It's 20 pounds. There we go. Final answer. We done.